This is Geometry, Semester 2 exam. This is going to be working with the law of sines and cosines. Picking up the Unit 7 from number 12, we're going to use law of sines to solve this. Notice that we're working with an angle, side, angle. So angle, side, angle is one of the methods we can use law of sines for because we know two bits of information. We know the side 27, and we can very easily figure out what this angle B is. So we're going to say that 51 plus 39, that adds up to 90 degrees. So 180 minus those two sides leaves me with 90. That makes that a right angle. So we're supposed to figure out what this side is. We could use normal SOHCAHTOA because it is a right triangle. But let's use law of sines. It's actually maybe a little bit easier. When we use law of sines, we look here at our definition and we see three fractions. They're all supposed to equal each other. We're going to pick two of those fractions to use. We're going to use the information that we already know. We're, of course, trying to solve for AB. We're trying to solve for this side, so we have to use what's called side C. Let's not put an X there. Let's call it side C because it's across from angle C. So I'm going to use C and the sine of C. And then I have to use B because I don't know the side length for A. B, angle B is 90, side B is 27. So C is our unknown. The sine of angle C, which is 51. B is 27. And the sine of 90. We only need to cross multiply one direction because that makes C get by itself already. So we have 27 times the sine of 51. We're going to divide that by the sine of 90, and the sine of 90 is actually the number 1. So C equals 2098. This 129, of course, is the obtuse angle. So here we're given three sides and one angle. To use law of sines, we have to use the opposite information that we know about. We know angle B and we know side B. Side B is across from angle B. Side A is across from angle A. And side C is across from angle C. So of course, we know the 129 and we know the 33, so we have to use the fraction that has B in it, and the other fraction we're going to use to solve for A has to, of course, be the angle A. So the fraction with the angle A in it. Side B is 33. Angle B is 129. Side A is 11. And I don't know what angle A is. So we'll cross multiply. We'll end up dividing by 33. So we're going to say 11 times the sine of 129. Then we're going to divide that by 33. Going to get a decimal of 2590. Now that's the sine of A. That means that the ratio of opposite over hypotenuse. The opposite side is 0.25, or a quarter, of what the hypotenuse is. So we're going to say that sine inverse of that equals the measurement of angle A. So with our calculator, we'll say sine inverse of our answer gives us 15.01. Number 13, we'll use the law of cosines. Here we actually have to use something different than the law of sines, because the law of sines requires 2 bits of information. We don't have angle A with side A, or angle B with side B, or we have angle C, but we don't know what the length is at the moment. So to find AB, which is across from angle C, so this is side C, this would be side A, side B, because it's across from angle B. We're going to use the formula. C squared equals A squared plus B squared minus 2AB cosine C. So to find the C squared, we're going to plug in the 22 squared, 27 squared, 2 times the 22 times 27, and cosine of 105. So we can type this into our calculator. 22 squared plus 27 squared minus 2 times 22 times 27 times the cosine of 105. That gives us 2541. C squared equals 2541. And those are feet, but we're going to take the square root of 2541. That would approximately equal the square root of our answer, which is 5.04. Something doesn't look right. C cannot be less than the other two sides. It's the biggest angle. Across from it has to be the biggest side. So let me see what happened here. Maybe I typed it in the calculator wrong. 22 squared plus 27 squared minus 22 times 27 times the cosine of 105. Whoa. I'm not quite sure what I typed in the first time. 1366.74. We'll divide that or actually take the square root of that. Take the square root of our answer, and we come up with 3697. That's much better, because that's longer than our other two sides. So for this one, it doesn't say specifically what to solve for. We're going to solve for the measurement of angle C. When you're using law of cosines, is what we have to solve for here. We have to solve for the largest side. So to solve for angle C, we have to use the formula that C squared equals A squared plus B squared minus AB cosine of C. Side C is across from angle C. Side B is across from angle B. Side A is across from angle A. So 21.9 squared, 10.4 squared, 18 squared, minus 2 times A, which is 10.4, 18, cosine of our unknown C. 21.9 squared, 479.61. 10.4 squared, 108.16. And 18 squared is 324. Minus 2 times 10.4 times 18. So what we're going to do is take our 479.61, we'll subtract the 108.16, we'll subtract the 324, and we're going to divide by the negative 374.4. You cannot subtract these two from each other. Because the 374 is hooked to the cosine. So we're going to take the 479.61 minus the 108.16 minus the 324 and divide that by 374.4. And that's actually a negative number. And I'm going to get negative 0.1267 equals the cosine of C. Now, of course, the cosine has to be less than 1, greater than negative 1, and that's what we have. So for us to figure out exactly what the angle measure is, we're going to take the inverse. And because cosine is a negative, that tells us that it's an obtuse angle. So we have our negative 0.1267. We're going to do cosine inverse of our answer. That's 97 6.28. That's the measurement of angle C.